We are going to be looking at two problems from section 5.3. Both of these problems involve solving equations graphically and then checking them, or excuse me, solving the equations algebraically and checking them graphically. And in these equations, both of these are exponential equations, and so this will be used to demonstrate the different methods. What I need to do first is set up my pointer, and so while I'm doing that, you can look at the problem and think about how you would proceed. In the first problem, what we have is 8,900 is equal to 5e to the x. To solve this particular problem, somehow we need to get this exponent out of the exponent position. To do this, what we want to do is use logarithms, and the logarithm base that we want to use is going to be natural logarithm, since this is an e to the 5x, and the natural logarithm is the inverse function of the exponential function e raised to a power. So what we're going to do is we're going to take the natural logarithm of both sides of this, and so we're going to have the natural logarithm of 8,900 is equal to the natural logarithm of e raised to the 5x. Now, the whole reason we're doing that is these natural logarithm of e to the 5x, these two functions just undo each other, and so what we're going to get on the right-hand side of this is just simply 5x. And so this is using the inverse property of the natural logarithm function and the e to the whatever function. And so I'm just going to rewrite this left-hand side, so I have the natural logarithm of the 8,900. To solve for x now, what we need to do is divide both sides by 5. And so if I divide both sides by 5, I'll get my answer. Looking at the calculator over here, and I'm going to try to make this bigger so that we can all see it. Let me lift it up a little bit. And once we turn it on, and clearing this out, what we're going to put into the calculator then is going to be the natural logarithm of the 8,900. Make sure you close your parenthesis, and then this is going to be divided by 5, and the answer we get is about 1.818. Actually, we need to round that up, and so the final answer for this we're going to have is the following. X is equal to 1.81, and we're going to round that up to 9. And the textbook asks us to round this off to 3 decimal places. Now, if we want to try to check this thing graphically, what we're going to do is in the calculator we want to put in 2 different functions. And I'm not sure why that showed up. But putting in these 2 different functions, the first function we're going to put in is, well, let's just put in the 8,900. And the second one we're going to put in is going to be our e. So I do second function, and then the e raised to the 5x. And we'll put both of these into the calculator. Now, our answer was just 1.819. And so when I set up my window here, I can set up my window. Let's go from, say, 0 to 2, because that's what my x value should be. Make a scale of 1. I went 1 too many here, so let me get rid of 1. And then the y values, we're going to have pretty big numbers in here pretty quickly here. So since I need to be at 8,900, let me just go from, say, I'm just making a guess here. So let's go from, say, 8,000 to, and let's go to, say, 9,500, so we can see a little bit. And let's make the scale on this to be maybe about 100. Let's look what we get when we graph these two. This is just a line. And here, there's our exponential function. Boy, that thing blew through there pretty quick. If I had changed the scale, you would see that line coming up here a little bit different. Let's change the window just slightly here and maybe make that a bit smaller. Let's make that, let's just say let's say 4,000 instead. If I do that, I'm going to have to change this. Let's make this say 1,000. Let's look at a graph again, and we can see where that exponential function starts a little lower, still comes up very, very quickly. Now, to solve this or to check it graphically, let's use the trace function here. And if I trace this across, I want to get approximately where the 8,900 is equal to this here. And notice that my answer here is 1.808. That's pretty close to our answer. If we want to get a little more accurate, we could go to the Calc menu, and we'll use number 5 for intersect. And our first curve is that one. There's our second curve, and where they intersect. Notice that our answer that we have here, 1.8187613, is about what we had earlier, so this checks it. Now let's go to the second problem. On the second problem, number 22 here, the first thing I want to do is get this exponential expression by itself. So I'm going to divide both sides by 21. So if I divide both sides by 21, and let me just do this on the calculator. If I take the 5,008, let me get out of here. I need to clear. If I take the 5,880 divided by 21, that gives us a nice number here of 280. So if I write that down here, I'm going to have 280 is just simply equal to 2 raised to the 3x power. Now again, we need to use logarithms to undo this exponential expression here. So I can use either natural logarithm or common logarithms. Let me just use common logarithm. So I have the logarithm of 280 is equal to the logarithm of 2 raised to the 3x. Now, using our power rule, I can rewrite the right-hand side. The left-hand side I'm going to just rewrite as logarithm of 280. But on the right-hand side, this is equivalent to 3x times the logarithm of 2. Now, to complete this, I'm going to divide both sides by both the 3 and the logarithm of 2, if you can see my penmanship here. And so this is going to be 3 logarithm of 2. And now we can go to our calculator to solve this. Now notice at the right-hand side, everything cancels but the x. And going to the calculator now, if I put in logarithm of 280, make sure you close your parentheses, divided by, and I need to divide by both the 3 and the logarithm of the 2, so I put in extra set of parentheses. My answer for this then is approximately 2.710. So going back down here, we have 2.710. And that's a decimal point, not a comma. And this completes both exercises 5 and 22 from section 5.3, solving equations algebraically. I did not check this one. Let me do that a second again. So if I needed to check this algebraically, let's change that to the 5,880. I got the wrong number in here. I need to get my 8 in there. I think that's correct. And the second one, let me clear that out. This is going to be 21 times, and then I have 2 raised to the 3x. And I need to get parentheses around the 3x. Extra set of parentheses. Sometimes that happens here. So I have the left side is y1, the right side of my equation is y2. Before I graph this on the window, my answer was 2.7 something, so let me just make this say 4. And I think the other scale should be okay. Let's look at a graph and see what we get. There's the 1. There's the other. If we check this using the intersect method in the calc, there's the first curve, second curve, and let's move the guess over a little bit. That's close enough. See what we get. Notice our answer on the bottom here is the same thing that we had earlier. Rounded that off, we have 2.710 like we had before. This then completes both exercises 5 and 22 from section 5.3.